So after we talk about the application area, so teachable machine is only application area. They have the platform, and then they provide you to create some application. So it's a tools for you to use, and then here we talk about the theory part. Okay, so we know more about machine learning. Okay, so teachable machine is a platform for the machine learning. So what is machine learning, right? So here we talk about the history first. Okay, having start with the history, you know what's going on, starting from the very beginning. So we have the computer system R1 1950. Okay, R1 1950. So at that times we only have computer for the army and only have the computer for the enterprise. So most likely they are mainframe system, and then they handle about the banking, they handle about the task problem. Okay, there are lots of calculations about the accounting and about the tasks. Okay, and later on around 1980, so we start to have our personal computer PC. Okay, and of course Mac. Okay, and then we continue to enjoy more and more technologies. And 2010 here, so we have our smart device, and then everyone today we have more than 5 to 6 personal computer or electronic device or smart device. Okay, in 1950, so someone predict that there are only five mainframe inside the whole world. Now I will say that for all of we guys, we have more than 5 devices. Okay. So when we have the computer, so we start to process some banking problems. Okay, so there are lots of the things about calculate the interest, about calculate the task, etc. Right? So there are lots of it. If then there are lots of case that we need to handle by the computer. When there are lots of different case, there are lots of different rules. So we need some algorithm to help us to manage the rules. Okay, just like in the library, so you have lots of the books, right? So when you have lots of the books, so you need to have some system to help you to manage the book. Okay, to help you to manage the book. For example, the index of the book, so that you can find the book inside the library easier. Okay, not just search from the computer. So you also need a useful or meaningful indexing system to put the index, okay, put the book number on your book, okay, so that you can find the book inside the library. And then we also need to have a good management system, how to manage the if then rules, how to manage the rules. So this is why we have the AI, artificial intelligence. Okay. At the very beginning, we only have the AI to handle the rules, so we have the rule-based system. Okay, so if you are a computer science student, definitely you know that when you need to match lots of if-then rules. Okay, so you have the tree approach, you have the graph model approach, or somehow you have the forward chain or backward chain searching approach, okay, to help you to fire the rules, okay, to help you to manage the rules, okay, so that your rule-based system or your rule base will not be messy, okay, will not be messy, okay. And then yeah, when the computer technologies continues to develop, so there are lots of problems that we find that the computer is not easy to handle. Most likely the computer only can handle 0 and 1 problem, right? 0 and 1 problem. But somehow in our daily life, there are lots of things that is not 0 and 1, okay, 0 and 1 problems. For example, I would say that today is really hot in Hong Kong, okay, today is really hot. But how you define the hot, okay? So hot, maybe someone say that 20 degree is hot, but someone say that 30 degrees is hot, but someone will say that 33 or 34 or 35 degrees is hot, okay? So how you define the hot or how you define the cool? So everyone they have different kinds of standard. Okay. So this kind of problem start to in computer field. So we need to find out some solution for us to handle this kind of these kinds of situations. Not only 0 or 1. So there are lots of different kind of degree of variables. Okay, not only true or false. So we develop different kinds of AI. For example, we develop fuzzy. Okay, here we start the fuzzy, and then fuzzy try to combine the statistical model, try to combine the normal distributions or different kind of statistical model into true or false, okay, into true or false, into 0 and 1. So it gives some degree of the computer to think about the problem, not just black and white 0 or 1 problem. So you have the certain degree to prove that is true, or a certain degree that is false, okay. So first is something like that. You combine the statistical model, it combine the statistic into the computer system, okay. Of course, there are lots of different kinds of AI here, okay. And starting from 1980, because lots of the people, they start to use the computer. We have the personal computer. So with the new technologies, we generate new problems. So there are lots of junk email. Okay, there are lots of junk email, and then we start to think: is there any method? Okay, is there any method to filter out the junk mail from our mailbox? And because every day there are new junk emails, so you cannot use a traditional if then else approach to analyze the junk email. Okay, so every day you need to have some new methods. Every day you need to analyze the new content of the junk email. Okay, so it starts in machine learning. Ask the computer, ask the machine, okay, to learn the content of the junk mail, okay, and then filter out the junk mail for us. So that's the start of the machine learning. At the very beginning, the machine learning model is really stupid, okay? Somehow we say that the rule-based system, or we say that the if-then-else system is more and more better than the machine learning. They can only deal with some stupid job. For example, they can find a way to escape from the maze. We call it pathfinding. Okay, so most likely at that time, the machine learning model, they are only deal with the pathfinding. They are only deal with some junk email problem. They can do a little. They can only do a little bit things. Okay, but around 2010, so thanks for the new network. So new network here we will discuss later. They have a new branch called deep learning. Okay, deep learning here, deep learning. Okay, and thanks for the GPU, graphical processing unit. So and we have the new breakthrough about the AI, about the machine that they can deal with. So if you still remember at that time, 2010, we have AlphaGo. Okay, we have AlphaGo here, AlphaGo. So AlphaGo, they start to deal with the Go. Okay, so this one is the Go game. Okay, so Go games, they say that there are lots of possibility, and then if you only use the if-then rules or traditional machine learning method, definitely you cannot find the solution in a very short time. But with the power of AlphaGo, they try to combine the deep learning with computer visions and, of course, with a reinforcement learning. So they try to solve the Go problem, and then they can find out the best solutions, optimized solutions in a very short time. And finally, it win all the Go game, even the top player in the world. Okay, so this is how it's a breakthrough of AI system, and then it turns out to a new age, how the computer or how the machine learning is broadly used in our daily life. So in our project, we are using deep learning here, okay? So it's only a subset. So it's a subset of neural network, and neural network is a subset of machine learning, and machine learning is a subset of artificial intelligence, okay? So again, what is machine learning? Okay, so what is machine learning? In our traditional modeling or traditional programming, so if you are CS or computer science or engineering student, or if you have learned any program before, so most likely we put our data and then we put our program. Okay, we put our program. Okay, so the most likely the program will if then else. So what you have done in Scratch, or what you have done in Unity, or what you have done in the interface, okay? So you cook some if-then-else model, if-then-else model. So we put both our if-then-else models and then data into the computer, and we got the result, okay? So this is called traditional modeling, traditional approach. In machine learning approach, is quite different, okay? It's quite different, okay? So we put the sample data, okay, and then we also put the expected result. Okay, that means here this is the set of the data that we have collected. Okay, that we have collected. For example, if you are working in a computer visions, okay, computer visions, okay, you want to recognize whether this one is $100 or $10 or $50, etc. Right? So you put the $10 and $100 in the front of the camera, and then you capture lots of the image. Okay, so the image is the sample data. That image is sample data, and then you tell the computer this one is $100. So this one 100 is your expected result. Okay, is your expected result. You put all the things inside the computer. Okay, inside the computer, and then the computer will help you to build the if then else. Okay, okay, that means the model. Okay, that means the model. In traditional programming, you build it by yourself, so model is here. But in the machine learning approach, the computer helps you to build the model, so the model is here. Okay, the model is here. So once the model is built, okay, so when there is a new data, for example, you use the camera to capture the new image. For example, you put $100 again in front of the camera. Okay, by using this model. Okay, okay, you put the new data and a new model, and then computer will tell you that whether it's a $100 or whether it's a $10 or not. Okay, okay, so this one is machine learning approach. The scientific approach, okay, is a scientific approach, is a algorithm that provide the computer the ability to learn, okay, to learn without being programming directly. Okay, that means you do not need to build your if then else. The computer helps you to build the if then else case. So this one is machine learning ML. Okay. Machine learning is very trendy, so there are lots of killer applications after 2010. Okay, after 2010, just after the AlphaGo. So it can be used in lots of different areas. For example, or the one of the most important killer application is the social media. Okay, social media. Machine learning learned how you interact with the image, how you interact with the videos, how you interact with your fans. Okay, they analyze the content of the post, they analyze content of the image, they analyze the content of the videos. Okay, and then try to do a matching. Okay, try to do a matching, and then give you lots of the information that you want. Okay, and you continue to watch this kind of information. Okay, so this is what the machine learning is performing inside the social media. It's also used inside the transport. Okay, so here is Tesla. Okay, Tesla is one of the I would say that's one of the most trendy things, right? So at the very beginning, we think that Tesla is not perfect. Okay, the battery of Tesla is not really good compared with other for example, the Benz or BMW. Okay, their battery is really bad. Okay, but what they are doing, they are providing good user interface for you. Okay, good user interface. Okay, and they also collect the data for you from you. Okay, the data from you, and then they try to do the auto driving. Okay, so why people love Tesla? Because Elon Musk always creates some crazy idea, wherever it's Skynet or wherever it's SpaceX or Tesla. Okay, they always create some crazy idea, and one of the crazy idea is the auto driving. Okay, it push how the machine learning or how the AI can help the others to do their work. Okay, and of course other kinds of application. For example, yeah, e-commerce. So this one is Taobao. Okay, but not only Taobao, eBay or other Amazons. Okay, they also analyze the shopping behavior, analyze how you interact with the image, interact with the goods, interact with different customer, etc. Okay, so they try to analyze your behavior and provide the landing page for you. Okay, provide the landing page for you. So don't think that because it's e-commerce, or don't think that because it's a virtual, so it do not need to care about the space. Okay, if you are in the shopping mall, you really care about the space inside the shopping mall, because you can put limited goods inside your shop. Okay, so you need to select the best one for the shop. Inside the this kind of e-commerce, you still have the same problem. Okay, people spend on the landing page, or people spend on your website. The time they spend on your website is limited, so you need to push the correct information to them. Okay, so the machine learning also analyze your behavior, and then analyze this kind of things, and then put it inside on your landing page. Okay, to help you to select the goods, or based on your interest, to select the goods for you. Okay, it also helps in the virtual assistant. Okay, so here is the chatbot. Okay, today lots of the customer service. Okay, they do not use the real people for the customer service. They use the machine first. Okay, they use the chatbot. Okay, and then try to handle the easiest. Okay, or the fundamental questions, or the basic questions from the customer first. Okay, they try to handle the common question from the customer. If they cannot handle, they will redirect to a real people to handle this kind of things. Okay, virtual assistant chatbot is one of them. That's why I have told you that my children, they will talk with Siri. Okay, they will talk with the chatbot to get the answer. Okay, so this is what we are enjoying the technologies now, and this is why we use the machine learning, because it really helps a lot. And of course about the financial service, and of course about the healthcare. Okay, so today, so you have lots of the application to discuss to discover the problem inside your X-ray, inside your CT scan, etc., etc. in the financial service. So machine learning try to become a fund manager. Okay, and then all the transaction, maybe they are not handled by real human, by real fund manager, so they are handled by some machine. So they will do some high transaction. Okay, high IO transaction. Okay, so they will buy and sell the stock in a very short times. Okay, and they do not have any feelings about the news. They do not have any feelings about the wording, so they just sensitive to the machine learning model. They just sensitive to the algorithm and to the numeric, to the data. So that's why they can, their performance is better than a real human. So we are using the machine to help us to earn money now. So divide and conquer. We will always want to break the problem into small parts, and classify the problem into small part and small part. Okay. So how we can classify the machine learning? Okay. So machine learning can be classified into two big areas. One is supervised learning, and otherwise is unsupervised learning. Okay, of course there are lots of different, for example, small band, for example, semi-supervised or other reinforcement learning. But here two big area is supervised learning and unsupervised learning. So supervised learning and unsupervised learning, the difference is the input. Okay, the input. Okay, so the supervised learning will provide the sample data, and also will provide the expected result. Okay, just like that, we have used an example about $100, right? We give lots of the image of $100. So this is the sample data, and then we also tell the computer this one is $100. Okay, so this one is expected result. Okay, so we give them the sample data, we give them the expected result for the training. Okay, so this one is supervised learning. For the unsupervised learning, we only give them the sample data. That means the image. Okay, it's a perfect example. We just give them the image, and then we do not tell the machine what is the expected result. So let the machine to cluster. Okay, cluster the image. Okay, and inside, for example, here inside the supervised learning, we can have two different kinds of things. One is called classifications. Okay, classifications, and other is called regressions. Classification means that the output is discrete data. Okay, the output is discrete data. For example, it's the image, right? So the image, one is $100, and other is $50, another is $20, another is $10 notes. Okay, so they are discrete data. They do not have any continuous or relationship between each image. Okay, each image. So this one is called discrete data. Discrete data. Or I will say that your discipline. For example, some of them are from computer science, and then some of them, some of us, some of you guys are from um, 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 business. Some of you guys are from social science. Some of you guys are from the other, for example, linguistic department, etc. Right? So you are from different department. Department are also discrete data because you do not have a continuous relationship between your departments. Okay. Regressions means that it's a continuous data. Continuous data. Okay. Continuous data means that they have the numeric relationship. For example, about your height. Okay. Or I'm 170 cm. So you have 171, you have 172, 3, 4, 5, 6, etc., etc., etc. So those are the continuous data. Okay, those are the continuous data. Okay, how tall you use the continuous data. Okay. Yeah, and one more about the discrete data. For example, male and female. Okay, male and female, they are discrete data. Okay. And if you are year one student, year two student, 3, 4, 5, 6, you do not have 3, 4, 5, 6. Yeah, so they are the continuous data. So you have two different kinds of things. Discrete data return true about, most likely return true about the labels. Okay, labels, and it's a classification problems. And then continuous data returns you a value. Okay, so it's a regressions problem. Okay. For the unsupervised learning, so most likely we only care in this course. So most likely we only handle about the classifications. Okay, classification problems. Okay, so we will not handle the others. For the unsupervised learning, so you have two different kinds of problem. One is clustering. Clustering. Okay, so clustering, I have told you that you give them lots of the image, and then the the what the the machine try to help you to cluster the image. So if you have used the series of, you are Android user, right? So you have take lots of the photos, and then the Android or iOS, they will try to analyze your photo, and then cluster your photo. For example, this photo is about the human, or this photo is about, they use the recognition of your face, right? So this photo is from your family member, is from your wife. This photo is from your children, etc. Okay, so this is clustering. Okay, so they do the automatic clustering without you input. This image is the people inside is my wife, is my mother, father, etc. Okay, the computer try to automatically give the label to your photo and then do the clustering. Another clustering, right? Clustering example is about the customer. Most likely customer will not tell you lot of things about their behavior. For example, their age, or the item that they want to buy, or some sort of things. Okay, so we analyze their behavior, and then throughout their behavior we try to cluster the customer. Again, we do not have an expected result. Okay, we just want to help them to form into groups, form into different cluster. Okay. And another things for unsupervised learning is about the dimensional deductions. Okay, so if you are handling lots of the data, for you have collect lots of the log data, so there are different column. Okay, so yeah, most likely for a e-business. Okay, for a Amazon or Taobao. Okay, such kind of websites for the shopping, right? They will collect 100,000 or even 200,000 dimensions. Okay, they will collect all the information that you perform inside their websites, even every click on the goods, and then even the information that you have input or they have collect throughout your behavior, throughout your logs. Okay, so there are lots of data loss of data is loss of the data are useless. Okay, so we need to reduce the dimension and filter out the useless column, useless dimensions. So this is how we use the machine learning to do the dimension reduction. Okay, so if you have learned some, if you're a computer science student and then you have learned some algorithm, so definitely if you do the dimensional reduction, you use the PCA. Okay, if you do the cluster array, you use the k-mean cluster array. Okay, so so after we have taught about the machine learning, and then we'll taught the one of the subsets of machine learning is neural network. Okay, neural network. So deep learning is coming from neural network. Okay, so we learn the neural networks first. So neural network is inspired by our human brain. Okay, it's inspired by our human brain in 1950 to 1960 something. Okay, so inside our brain we have a huge neural network. Okay, huge neural network. In this huge neural network, so we have lots of neurons. Okay, we have lots of neurons. Okay, compared with the other animals, so our neuron is more complicated than the other animals. Okay, and thanks God, right? So for the other animals, okay, when they go outside from their mother, most likely they have already put lots of the data inside their neurons. So that's why the other animals, they know how to walk, they know how to run maybe 30 minutes or 60 minutes. So their behavior is similar to their father and mothers. Okay, but for we guys humans, our baby, they need to learn 3 years or 5 years, so they behave like their father and mother, and then we need to learn for us, maybe we need to learn 20 years something to put lots of the things inside our brain. Okay, so at the very beginning we have lots of space for us to learn different kinds of things. Okay, and for yeah, different person, they can put different things inside their neurons. So what's happening? So what's happening about our neurons, or what's happening about our learning? Okay, so yeah, of course, we have mentioned before, we need to draw our attention first. Okay, draw our attention first. For example, from our eyes or from our ear, we need to draw our attention. Okay, so maybe we see a bottle. Okay, we see a bottle, and then we put the image of the bottle inside one of our neurons. Okay, inside one of our neurons. And then if we teach them to drink the water, by using the bottle, okay, so we put the water inside another neurons. Okay, inside another neurons. If we repeat this kind of behavior, that means drink the water by the bottles. Okay, so we increase the chemicals connect with these two neurons. Okay, with these two neurons. And then finally, we know that we can use the bottle to drink the water, and this is how we as humans learn the things. Okay, from our attention to short-term memory, and then later on to our long-term memory. Okay, so the computer scientists, they try to use this kind of concept and then use a mathematical model, okay, to simulate the neuron system. Okay, to simulate the neuron system. So you see, so here we have lots of different kind of nodes. Okay, so this kind of nodes is simulate the neurons. Okay, and then we have lots of the connections to connect each node together. Okay, and this kind of connections is just like the chemical simulate here. Okay, but what is the concept in between? Okay, so here we use a working example to try to let you more about how a mathematical model to simulate our process inside our brain. Okay, so here we have two input, x1, x2, okay, and one output, y. Okay, one output, y. So those are the nodes, and then we have lots of the connections between each node. Okay, so this one we call it a fully connected network. That means all the nodes, they are connected with each other. You see that, right? All the nodes, they are connected with each other. Okay, And then all the knobs all the knobs here, x1, x2, when they are connected with each other for all the lines that they connect with each other, we will give them a weighting. Okay, so here this line is W1 and this line is W2, W3, W4, W5, W6, etc. Okay. When the lines are connected to each other, and then we will calculate the new value of the new knob. Okay, so the new value of the new knob is the weighting times the input, and then we sum up them together. So here for the x1, we sum up the weightings and x1 and plus the weighting with the x2. Okay, so we put these two lines together. Okay, and then the x2, we have the similar settings. Okay, so when you're looking at this equation, it's only a linear equation. Okay, y equals to mx plus c. Okay, but we sum up all the y equals to mx together. Okay, and become the output. Okay, and this is how we simulate our brain. Okay, so what's going on, right? When we have the simulation, when we have the input data of x1 and x2. Okay, for example, x1 is 5, x2 is 4, etc. Right? So we will assign some random number to all of the rating. Okay, so we assign the random number to W1, we assign a random number to W2, assign the random number to W3, 4, 5, 6, etc. Okay, so when we assign the random value to the W, and then we combine the x1 and x2 together, so we got all the answer of x1, x2, and the estimate output y. Okay, y. Okay, by compare the estimate y. So here I do the calculation for you, right? If you want to do the calculation, you can still continue, but this only a example to illustrate our idea. I will calculate for you. So the estimate y is 0.82. So it's different from the true value. Okay, the true value y is 1. Y is 1. And the estimate value y is 0. Point h2. Okay, so there is a error in between. Okay, of course there is a error because we just put the random number into it, right? So definitely the output that we get outside is different from the real wise. Okay, so it turns out there is a error. So we use the error of the y, and then we use the error of the y to calculate the error of h1, to calculate the error of h2. Okay, according to their weighting. Okay, for the largest number, the largest value of the weighting, they are responsible for a largest error, right? And then we use the h1 and h2 error to calculate the new weighting, w1, w2, w3, w4, w5, w6, etc. Okay. So so after the first cycle of the calculation, so all the random value of W1, 2, 3, 4, 5, 6, they have the new value again. Okay, so with more and more data. Okay, so with more and more x1, x2, and y pair. Okay, so the weighting of the new networks of this kind of slope. Okay, they are close to real values. Okay, they are close to real value. So that's how the new network is learned from your data. Okay, they are tuning the weighting. Okay, there are lots of weightings. Okay, they are tuning the weighting, and then so that's they can minimize the error of the model. So after maybe few thousands of times, they tune the slope of each weighting. Okay, and then it turns out a reasonable or acceptable accuracy, and that is how the neural network is learning the weighting, is learning the parameter from your real data. Of course, the linear equation is only a small or fundamental part of neural networks. Okay, we use the linear equations to calculate the things, right? But there are lots of nonlinear approach. Okay, nonlinear approach. So this is another mathematical problem. So inside each of the knobs, beside the linear equations, beside the W and X pair, so we also add some activation functions, or we call it bypass function to it. Okay. So we have the sigmoid, we have the tangents, we have the value, okay, maximum, 0 or x, okay. So after, if the summation of all the w and x pass the 0 value, so we return the x, the true weighting, to the output, okay. So value is one of the most commonly used activation function in deep learning or in neural networks. Okay, so if you are computer science student, you need to you need to learn about it. But if you are not a computer science student, so just know that we will combine all the linear equation together, and then by using the activation functions, okay, we can turn the linear approach to non-linear approach. Okay, so this is how the neural network, they try to perform like a human brain. Okay. Of course, there are lots of activation function, and yeah, you can learn it later. And after you have learned the neural network, and now we are here. Okay, we are only here. Okay, okay. And then there are lots of different combinations of the node models. Okay, so there are lots of different node. Okay, and then there are lots of different connections between different node models. When you increase the capacity of the neural network, so we try to go from neural network to conventional neural network. That means the deep learning. Okay, so here is one of the deep learning approach, and here is another kind of deep learning approach. Okay, okay. In our project, we are working in computer. We are working with the CNN. We are working with Squeezenet. So it's these two kinds of deep learning approach. These two kinds of graphics. So how the neural network is transformed from the CNN? Of course, we increase the capacity of the node model. We increase the capacity of the connections. Okay, so why we increase the capacity of the connection and then turn it into a convolutional neural network? Okay, CNN. It can be a deep learning, and then they can do lots of the calculation for me, especially in the computer vision area. So what's going on behind? Okay. So here is one of the image, right? So here is one of the image. So throughout the CNN or throughout the deep learning, they try to extract the feature of your image and then combine the feature together. Okay, combine the feature together, together. Okay, into some abstract form. Okay, into some abstract form. And then we try to linkage those abstract form from a vector and match with the labels, match with the classifications. Okay, okay. So this is how the deep learning is running inside our computer visions. So here is come a easiest way to understand what's going on, right? So we classify them into low-level feature, middle-level feature, high-level feature, etc. Okay. So here is the image, right? So we want to find out some interesting point of the image. Okay. For example, there are lots of the straight line. Okay, straight line inside the image. Okay, we use those straight line as a low level feature and then combine with some bigger, yeah, bigger point in the graphics. Okay, bigger area inside the graphics. Okay, and then we turn these kinds of middle level feature to another high level feature to see whether it's a wheel of the car or not. Okay, okay. If we can find out lots of these kinds of area inside the image, we can say it is a car or is other kinds of vehicle. So this is how the deep learning is analyze the graphics and then combine the feature. Okay, they extract the small parts inside, small feature inside your graphics, and then combine them together. Okay, and then combine them together. Okay, so they learn about the distributions of your pixel. Okay, distributions of your color. Okay, distribution of your color. And then if they can find the machine learning, deep learning model, they can find lots of similar feature inside your image. They will say that this one is car, or this one is table, or a cat, etc., etc. This is how the computer vision is. This is how the deep learning is using in computer visions. And then yeah, one of the CNN is called Squeezenet. Okay, Squeezenet. So again, it's a subset of the neural network, is subset of the deep learning. So Squeezenet is some pre-trained model that you can download and use. So that's why when you training inside the Google, inside the yeah, other kinds of platform as a service, you need not to spend lots of the time. You need not to spend month or even year to train up lots of the image. There are lots of pre-trained model, and then you can use the pre-trained model to add your image inside it. Okay, to add your image inside it, and then you can enjoy a shorter training model, shorter training times with the same accuracy. So the Squeezenet is around 50 times. Okay, less than your other neural network. Okay, so it's quite good, and then the performance is good enough for all the webcam. Okay, or we call it browser applications. Okay, so that's why we are using Squeezenet in most of our applications, because it's really fast, and then yeah, they have the similar accuracy with the other neural networks.